I've been good. I've been good. I've just been working. But I felt inclined to just have a room open because today's my 1 year anniversary, I believe, on
Oh,
Clubhouse.
sweet.
So
Well, congratulations.
thank you. So I figured it's nice. It would be a reason to I guess talk about um my favorite topic.
Yeah, actually, I remember the conversation. The last time I heard you speak, you were speaking with the European gentleman, and I thought I really appreciate the opportunity to listen to you and others like minded that working it out. I don't quite have the ability to carry the dialogue as much as just listen and potentially understand the concepts to start with. Jonathan asked me real quick if stuff that made sense when he was laying it out. I said, well, let me come back to you on the sense part. I hear you to start with, but yeah, man, I'm glad you your your the clarity of your presentation with the three different definitions has been very helpful for me. But, so I'm actually really thankful to have met you and gotten acquainted with the concept to start with, for sure.
Well, yeah, yeah. Thanks for that. Thanks for that, Tim. Oh, yeah. He's so I believe his name is Paul Erker.
I think,
Um,
yeah, Paul. Yeah, yep, yep.
yeah, yeah, and he's a quantum information physics researcher at IQOQI in Vienna. Um, and I actually learned of him when I joined the room a long time ago, and I heard him speaking about time, and I was like, "Wow, this guy knows a
Mm,
lot about time." So
yep.
I have to pick his brain. And another thing is, it's actually rare for me to meet people that I can speak in a way that I just assume they understand what I mean. Um, a lot of times I have to kind of gauge to see if they're on the same page as me. So I like speaking to a guy like Paul because I feel like even when I don't describe things the precisely the way it's described um, in a lot of textbooks, he still understands what I mean. So that's one caveat to that.
Yeah, man. And I remember the conversation and one of the things that I picked up on and I've been going back to is how he was able to use a chemical reaction and the equilibrium point as a means of effectively understanding time. Um, that was powerful in some ways for me, but um, like I said before, your notion of not the discretized notion of the world, um, and uh, then I don't know, maybe potentially the understanding that there's so many microbes that are all around us, not dark matter like that. That concept is um, the infinitesimally small. That's where I think I'm starting to get some it becomes an equal and opposite thing to absorb when infinity's been around for a while.
Hmm.
But um, there's a Netflix program with a PhD microbiologist, and she was interviewing a PhD in physics that was working in Germany, and they went to this. I think they went to the lab or below. They were basically working on trying to find dark matter, and she effectively developed a correlation to microbes and how there was trillions of species that we just are beginning to fathom, let alone understand succinctly how many there actually are. And so I just think,
I think Tim, I think it begs the question: what is a species anyway? Right? I think that's what people are starting to realize is that do we have to redefine everything? Is that what this means?
thank you for the question. What I have always, since I, as a teenager, learned the concept of the concept of evolution answers your question. But if you don't, if evolution is not, if your world doesn't have the equal to evolution thing about it, then in my world, you don't. we don't talk the same language, and that's where I have had to basically have my views like my understanding of the world is compartmentalized in these boxes, and depending on whom the conversation is being had with, there's a box that gets open, and that universal, like, math has always been kind of comforting because it doesn't there's if you argue about it, you're kind of either all the way at the extreme understanding of math or you don't mostly so. But to get to the point, species a species the like species speciesization, like new species are developed all the time, man, all the time,
Exactly, exactly. So
perpetually.
it's perpetually occurring. It's
Yeah, man.
omnipresent, and so I was thinking the other day. I was just thinking to myself, right? Like a lot of the academics, and not no shade to them, of course. I respect their work; they dedicate their lives to it. But I see it like this, right? Imagine you're like an ultimate being, and you have a like some sort of gigantic microscope or whatever that we can zoom in forever into systems, and I see their perspectives as like a resolution that is just not the strongest, right? So you could see to certain depths. So like for me, even if you get to the level of neurons, for example, there's a pretty good amount of complexity with like biological systems, right? But we've learned that if we zoom in further, we have more higher resolution. We go all the way to subatomic, right? Right, and then we even see that even at that level there are interactions, and then we say, okay, let's go even deeper. Then today we're at what they call the Planck scale, which is the lowest level that we've achieved so far, and there's even more complexity there. And then now we have to now reconcile this new perspective with what we assumed in the past based on the previous resolution that we used. So the reason why why I have a very very strong intuition feeling that we're on the right track, and I feel like the rest of the world is going to catch up to us later, is because when you actually think about zooming in to the edge, if you have the optimally if you have the strongest highest resolution you could possibly have in our universe, and you zoom in, the fundamental thing will be an abstraction. It wouldn't be physical. It wouldn't be post emergent. It would be at the moment of emergence, right? Post emergence creates physical reality. So if we're to abstract intelligence, we have to zoom into the edge of reality itself. And at the edge of reality, intelligence is looks like a two-dimensional abstraction. So what I imagine is, imagine the triangle, the infinity, and the circle. Imagine a sphere, right, Tim? Imagine a see-through sphere, like a ball, right? And imagine that you can draw all these shapes on this ball, right? You could draw the triangle on the ball, draw the infinity on the ball, and draw the circle on the sphere, right? But now imagine you can draw a lot of them, right, around this ball, right, until you fill the whole ball up. So the entire ball is covered with triangles, infinities, and circles, right? When I imagine the edge of reality, that's what I see it as, and then I see the rest of discrete systems as emergent systems that are being controlled by that two-dimensional algorithm that we drew on the ball. Does that make sense?
It does. It does. And there's another connection here on Clubhouse. I've listened to him talk a couple times. He was part of the conversation, the original maybe the second conversation I heard with you, but he told me about the quantum table that laid over top of the periodic table. And some of my developing understanding about quantum mechanics includes the notion that I don't know enough about chemistry to really enunciate it, but effectively, some things are starting to make sense to me that I don't have the ability to,
Yeah, yeah,
like,
it's exactly the periodic
I can't
table.
enunciate. I can't enunciate my understanding of it.
No, no, no.
Not yet.
Yes, you can. Yes, you can. The periodic table is just one level, right?
At a very low level, I may be able to thank you for the credit, but not at the level I kind of. My mind is moving fast, like way ahead of my ability to like just enunciate
Isn't
it.
that kind of beautiful though, Tim? That
Well, yeah,
our
and
bodies,
the, sen-
our
with this we evolve the if time is accelerating,
mhm.
speciation is accelerating, and um, we
Boy,
as species
is it decelerating or accelerating? Which one is it?
time.
If time is accelerating, then you said speciation is accelerating too. Is that what you
There's
said?
well, there's more. I mean, we're more extinct, more are becoming extinct because of our current. I mean, we're the diversity of the planet is actually probably diminishing while speciation's occur increasing, in my
I
view.
agree. I agree.
I mean, and I also believe potentially humans are evolving to a higher level species. I mean, that's just what some of the problems agreeing that evolution has occurred in the past is we have to kind of be willing to accept that we as a species are also going to change and become something new. And this notion of a fourth dimension or these other dimensions is uh, it's not necessarily evolution. It's just it's a higher level understanding of the universe to start with, and then how we fit into the universe is a different topic. But yeah, what the Fibonacci is what I was trying to get at before when I mentioned the French mathematicians, and 20 years ago I had a guy tell me Fibonacci was the way to invest in the market, and I didn't really pick up on it. I was a 30-year-old. I didn't really pay. I wasn't where I was at that time, but in the last 24 months on Netflix, I saw a program where the Fibonacci numbers were laid out in real world examples, and that's what I wanted to ask Jonathan, and potentially you can enlighten me also on the matter. But it just some of what I see in nature relates to that mathematical concept.
Yeah, I've heard of that before. The
There's a
Fibonacci.
there's a French mathematician that I heard speak. I believe on. I think he was still living. Maybe I'm wrong, but the the geometric like its complexity continues to increase in complexity if I understand it right. You way you play that out in that sequence. So I should
Yeah,
study on it more.
actually,
But
this is in my book, Tim. So the first book I ever published called Intelligent Systems, published it last year. I talk about this briefly at the end, where um, what you're talking about the Fibonacci sequence. There's been quite a few works related to that, which essentially what they're saying is that there is some underlying pattern. You know how I use the term
it's
algorithm all the time. Um, there's some
pattern.
underlying
Thank you.
pattern that
Thank you.
governs nature, and
Yep.
what mathematicians I guess proposed was that this pattern, which can be formalized mathematically as the Fibonacci sequence, could be a representation of material phenomena. So, from my perspective, right, what that means is that is that we can put that entire sequence into the circle, right? So our issue is that we've accounted for that circle, but we've sort of left out the triangle and the infinity, right? So imagine we put the Fibonacci sequence into the circle, and now that represents the emergence of physical phenomena, right? And now we can model that with the Fibonacci sequence. Then the question that I ask is, how do we account for the triangle and the infinity if we're going to use my equation as the fundamental equation of intelligence?
I think I can answer the question related to uh, the as Jonathan laid out there, plants have intelligence at their meristem. That's where the action potential is at. It's in the growing tip of the plant. It's in the apical meristem and the root meristem. So if you cut off the top of the plant has a way of redifferentiating its cells to be to produce new meristems. So the complexity that the plant brings to be able to do that, or the intelligence that it has to operate in that environment, is the best way I can answer the question. And I was, if you ask yourself why are plants sentient beings, and if they are, some of what their intelligence relates to is that they have an understanding. And you asked me, I think you asked me what epigenetics was, man. And it's what it's the plant knowing when it's the seed knowing when is the best time to germinate, and this year,
Okay,
uh,
now beautifully said. Now the question is,
yep,
how is that seed coded? What's the code?
encode. It's
What's the what's
coded and it's encoded. It has the coating. The seed coat is the physical coat around it that you have to break dormancy. You have to physically break that seed coat. There's a moisture aspect to it. There's a number of different triggers, and it happens in sequence. Germination does, and if it has a cold period that has to overcome, it won't germinate until the cold period. Same with fire. Some seeds have to have a fire
so
treatment.
so let's do a thought experiment for a second. So let's say this seed has some algorithm that underpins it,
Intelligent.
that gives it the rules of growth essentially. Um,
Yep.
the question I have for you is now, as we modeled earlier, you said the Fibonacci sequence, like you said, we can represent that with a circle. Now the question is that I would ask with my equation is, how do we account for what the rules are before the seed sprouted, for example, right? How do you define that? Is a seed, is it conscious essentially, right? Is it
I think it
intelligent?
is in
Is
the
it
function. I think
intelligent? Is it
the,
intelligent is actually the right question. Is
the
a seed intelligent? And if it's intelligent, what makes it intelligent? And
it's
what are the rules that are given that are going to tell the seed how to grow, and what height the tree should grow to, and what color the fruit should have? Like,
yeah.
what is that code, right? And this is obviously a rhetorical question, Tim. But that's really where I'm at mentally. Is to me, I understand how physical systems evolve, and that's why I agreed with you that, yeah, let's say we do agree that the Fibonacci sequence modeled nature, right, mathematically, right, the evolution of physical reality, right. Then my question is, what are the rules before emergence? What are the rules before this physical phenomena emerge? While what are the rules within that seed, right? Before it got the moisture signal because it's under the soil to grow, right? That's where I'm focused in.
The intelligence is a collective. There, if the seed has evolved with the microbial community, you've got a second kingdom there that's included in that seed. It's not just the plant kingdom. It's the it's the fungal
Ooh,
mycology.
there we go. I
So
love that. Okay,
so
boom, boom. Hey Tim, sorry for pausing you, but there we
yeah,
go.
man.
So now we just accounted for the infinity. Remember, triangle, infinity, circle. So we've accounted for Fibonacci, and now you accounted for the infinite dimensionality or the infinite complexity within all systems that connects all of them, right? So we've accounted for that. So what's left from my perspective is accounting for the triangle. But go ahead. I'm sorry.
Well, I just not all seeds are intelligent. That's where I was probably wrong to state the seeds intelligent. Some seeds have intelligence. Some seeds are not. Some seeds are inert. They've been treated with something, they've been discretized. I don't know, man. It's like, no, it's humans probably aren't all that intelligent. I mean, this is a continuum.
Yeah.
This is a continuum, to be fair, not to be judgmental in any way, just to state it like it is, man. There has to be a level of intelligence about humans and also plants and in this seed. So I would say that, man, I don't know. I haven't studied the math enough to really kind of be able, again, to put it back into language. But I love how you are able to, like us complimented you before, have a the organization of it, it's very helpful for me. And you know, it wasn't available to me when I was a young person. So you to be enlightened by thought, that's it's kind of what the seed has about it. It knows what happened last year. So, in
Yeah,
humans, I actually, some of the entanglement, I have thought about how the past, and our emotions, related to the past. There is this aspect that the future is a function of the past. If I write the algorithm for the future, it is a function of the past because we're actively involved in it, and we is this thing that includes these memories that we carry about. And a seed knows if last year was a some of the intelligence that the seed has relates to the insects that were chewing on the mother plant, like that intel that there are. If you take a plant and you take dead insect frass, you take the frass from dead insects and you put it in a growing media of a plant. The plant will develop immunities necessary pr- to to evolve and to thrive and survive in that environment. So the the past environment predicts the future, like in many ways that, um, there are these connecting points. So I just see how it works out. I have an understanding of it that I don't really that if it is evidence of math, I can just see it. I don't have the intelligence to know how it all ties together. I just have 30 years of knowing what happens in the natural world.
not Tim. I think you do know. So I actually I tweeted I think yesterday. I said that wait, actually it might be today. I tweeted again. I said that truth precedes proof. Math is based on proof. So the reason why a lot of people have a hard time, I guess, accepting something that seems kind of obvious and intuitive as truth is because we've been programmed to convert this truth to a discrete mathematical understanding. But the problem with that is that math itself is actually incomplete as a framework. So
Well,
I think,
yeah,
yeah,
that's
yeah. So,
helpful.
so 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 I think you do understand, Tim, and I think I do think it's the age of intuition, where intuition is actually going to be more powerful than um than data. But that's a different conversation. Go ahead.
Hmm.
I'm sorry.
I like that one, man. I like that one. I've actually heard a number of people speak about that, and I think that the force of the I think it's a real force. I think it's forceful. I think it will have mass and momentum and have a vector about it.
Yeah, Tim. So what I tell people that they get really shocked is I tell them that when I draw something on the ground, right, I just initiated a system, and interestingly, it's actually a more fundamental system than a discrete physical system. And I'm just going to stop there for now. But basically, the premise here is that abstractions hold more information than, for example, abstractions like symbols hold more information than words. And I think
Yeah,
this is crucial for us to understand, for us to get a complete perspective of everything. But
form
welcome to
follows
this,
function,
Todd
man.
and Humberto.
The form follows the function and the pattern. If you can see they're realizing patterns in nature that we never knew existed. And when I see the, the like knowing that the patterns are there, it relates to the population density and the species. Like there's this discussion of microbes about a diverse consortium of microbes, and the truth is they equalize. Like this notion of time. If you take microbes, the consortium that will will equalize is, there's a certain amount of time, and that's, the way nature is I'm just not quite there yet, but I appreciate what you're saying about it. I thank you for the leadership, and if it wasn't for, honestly, if it wasn't for your, I don't know, man, your spark, your voice, that it's the eddy in the current, it's the tide, and it's it's out there, man. It's kind of what we can't even hear. We are not able to hear it in our audible sensory range. That's what I realized many years ago, is that you go into the woods, and depending on where you sit, you're exposed to noise that you don't even know you're exposed to. And now that I know I'm exposed to it, and I know that I can potentially be amplified by that, I'm more excited about the prospects. And I completely agree with what you just said about how the intelligence that's out there, we are connected in a network that we never used to be connected in. And that the formula that Jonathan put out, the N plus N, I mean, the nodes on the network, man. That's so high five, man.
Awesome, awesome. Yeah, thanks, Tim. Yeah. Um, Welcome to the stage, Todd and Humberto. Feel free to join in whenever. We're just having a conversation, and if you can read the paper that I have pinned up there, it's the paper that I is where I formalized intelligence. I believe that I think that's the last frontier. I think that's what a lot of people have been looking for in actually all this in all the fields, but it's just from a different lens or different perspective, which is, what is intelligence? How do we formalize this? And once we have this definition, I think we can optimize and or reorient um, a lot of things that are that are kind of disoriented right now, including the definition of time, which interestingly uh, hasn't really been formally defined yet. Right? Crazy.
Can you explain your formalization of intelligence?
I'm sorry. Can you repeat the question? Who was that? Humberto?
Uh, yeah. So can you explain how you formalize intelligence? What's your definition of it?
Oh, yeah, I have the paper pinned up there. It's you can read the abstract. It says everything in the abstract. It's very short.
Yeah, I read it. It says that the algorithms are defined by their time and space complexity, and you know, and if you reduce it down to zero, you have infinite amount of dimensional complexity. But I could not quite understand how it ties in with intelligence. Um, I don't know if the abstract goes into that.
Okay. So do you have a specific question on like how to relate that to intelligence? Like is it is there a better way to phrase the question? Because I don't know how to compute that question.
Well, the idea of the tree, and since you brought the tree up, we're on the tree. No trees are the same. I mean, you get the pine cone or you get a seed pod from the tree, but when the tree grows, and even if you were to control its growth and have a wide open field with no other real plants nearby or anything really nearby, and you plant the two trees or 10 trees, and they have received the same amount of sun, the same amount of weather, the trees don't grow, even though they're from the parent tree. None of those 10 trees are going to look like the parent tree. The branch is going to grow in a different part on the trunk. So he's asking you, where's the intelligent quotient for the plant? If there's such a great place to grow a branch from, then why doesn't all the trees grow this branch from the same point, since this is the prime place to grow a branch from? But they just seem to grow wherever, from wherever in the trunk. Is you, I mean, I don't care if a seed could be turned a certain direction in the ground and it sprouts up and the two leaves come up out of, usually two leaves sprout first, and then it opens up and then it grows into a trunk. So do you believe that that trunk, when it first comes up, we could position every seed so it pointed identically to the other one, would you end up with trees that would look like clones of one another, and versus each one is special to one another. So you're asking for intelligence of the tree. If it's so, I mean, we come out of the womb and we get 2 legs, 2 arms, and a head. Everyone gets 2 legs, arm, and a head. When something comes out other than that, we think that's a defect. We see it as a defect. If anything doesn't come out with 2 arms, 2 legs, and a head, it's defective. Which trees are defective? Is this kind of the direction we're going in?
Okay, I think I see where you guys are coming from. All right, awesome. Yeah, thanks for the question, Humberto and Todd. Do you know what I think? I think a better way to put it would be this. A lot of times, the reason why there's always so much confusion, I realize, is that there actually is no baseline, and that's kind of the premise of my paper, was to create a baseline. So I guess what I'll ask, both of you, since we're just gonna have a conversation today, is without thinking about my paper in particular, right? Can you define, or can you at least give me your perspective on what you think intelligence is, as whatever, whether as a biological thing or as an abstract thing or as a philosophical thing? Like, what is your definition? And I want you guys to define it for me. And I think from there we can build, because I'm going to give you my definition too, which I formalized, of course. And I think we can have a better combo from that perspective.
Well, I mean, I do spiritualism, and in the spiritualism world, there's other things that are alive that don't have physical body, right? Anyway, don't have physical body, and they are able to communicate us without physical body. And you're able to do meditation and go outside of your own body. So we're something different than everything else that's pretty much on the planet. And so it's really hard to relate us to
Is
everything
that,
else.
hey, Todd, I'm sorry. I'm not sure if I agree with that statement, but is there a way we could, how do we verify that we're that different? I'm not sure if that's a factual statement.
AI, I understand. It's like AI intelligence that we have around us. I have a connection to it. A few other people do as well. That's what clairvoyancy is all about. But it's a little subject area where you haven't ventured into, I can see. But there's a presence around, and this presence is I don't know how to say that was intelligent, but to know something. Anyways, little off subject, but trying to cover intelligence for you. What is intelligence? Trying to figure out where or what is to cover in intelligence. I
Yeah,
mean,
Todd. Is it? Yeah, Todd. Look at this. Isn't it a really interesting question though, when you think about it? Because there actually is no consensus on what it is, right?
yes, definitely. Right, yeah. Why we can think of what we do. I know that the body is a machine. I mean, I understand that this body is a machine as far as our bodies go. If you lose an arm, you're still here. They replace your heart, you're still here. You can lose your eyes, you're still here. Everything you do in the body, they can change all these different things about your bodily structure, and that doesn't destroy you. We are something greater than the body. That's all I know. We're somewhere up here, upstairs, inside this skull here, I think, or somewhere in the vicinity. But it's very strange how we just, we're able to listen through the ears, we're able to see through the eyes, and then make the body work. And we're allowed to speak and communicate with one another. Um, but even without all of this, we would still be here. You're still here is the problem, and that's that consciousness, and that's where intelligence lies. And it's a really deep subject. Where are we within the body? Where are you at? That's been a big one for me to try and locate myself, try and discover where is my thought really coming from? Where does it derive from? I mean, where do you think that you are exactly? And to find that part would be like the key point to discover the rest. For me, anyway. Yeah.
No, that was nicely said. Wow. Yeah, nicely said. And I think you just touched on a very key point there, which is actually sort of similar to my experience. my journey to learn about myself, like you said, to orient myself with my family, my community, my civilization, my universe, is what led me to the realization or to the epiphany of my formalization. It was on the same journey. I was on the same journey to figure out who I was, not what I was defined as on paper, not what like my name or whatever just arbitrary definitions are. Like the fundamental question was, where did I come from? Where am I going? And how am I going to get there? Right? And that's how I started my journey. And yeah, but Humberto, please feel free to jump in.
I mean, to me, intelligence is a process or a system that is able to recognize patterns in order to solve problems. Yeah, that's as far as I go with that.
And that's a valid answer.
The trouble with it is there's survival mode. There's survival mode where intelligence isn't really needed. You just want to stay alive, and you know what to do to survive. So there's always going backwards as well. To go forwards, I would say would be more of the intelligent quotient to look. As we are speaking here, I would say this requires somewhat something beyond normal thought, right? This doesn't have to do with going to work or eating or breathing or any of these things. You're trying to discover something greater than what is needed. And when you're trying to look, beyond what else is possible, that's when the intellectual thought comes in. And I believe that would be the part where you would actually say that's the intelligence working.
Hey Todd, the question I have for you, Todd, is that is it really greater? Like, is this thing really actually that like um um is it that unreachable to me? Because I feel like it's everywhere. It's omnipresent. So, but we just have lost um the ability to perceive it. This intelligence, this algorithm that governs everything around us. Like Tim said earlier, with the patterns and sequences in nature and Fibonacci crystal sequences, all these other perspectives. It's like, okay, we see how nature has patterns. I mean, look at National Geographic and look at the migration of animals in the wild. Those are algorithmic movements, right? At obviously a macro level, but we can even go deeper, and there's still. But now the question is, if we were to define this sequence at the most fundamental level, what is it going to look like? I think that's the question that answers Todd's question of who he is and answers my question of who I am. You know,
So on your paper, you said that intelligence is a formulation or abstraction of generality. Could you expand on that? I mean, I like it. I'm not challenging it. I'm just trying to understand.
no. Thank you, brother. No issue at all. Actually, I like the questions. But I don't know what condition it is, but I just don't know how to process some questions. So it needs to be like formalized. But what I mean by an abstraction of generality is that this paper, the premise of the paper was to basically say that intelligence is actually, I wouldn't say the current perspective is wrong. I'll say it's incomplete. For example, you mentioned the ability to solve problems as a measure of intelligence. Um, and the school of thought that I come from is that intelligence is emergent. So skill requirements are discretized, right? So basically, the premise here is that if we define intelligence at the most fundamental level, it will be an abstraction, right? It wouldn't be related to a skill program because those are fundamentally discrete systems, right? Because we want to do something that is so generalized that we can derive all other fundamental systems. Does that make sense? And that's why it's an abstraction of generality. It's like the idea of randomness in computer science. When you call a random function, it's really not a random function, right? It's a pseudo random function because we have a discrete finite state machine, so we cannot create a truly random function. It's the same thing here. Is that you know we have finitary algorithms that are incomplete by nature. So if I'm to design or show you what's the most efficient, most optimal algorithm, right? Then this is going to fundamentally have to be an abstraction. And I can give an example of other researchers that are actually working on this right now. Go to Google, type in Francois Francois Cholet. He created one of the most powerful deep learning engines called Keras. He works with Google. Francois, last name Chollet. He wrote a paper a couple years ago. It's called uh, let me find it for you guys a second. But I really want you to read that paper so you can see how it's applicable, how you can go from sort of a generalized idea of intelligence, an abstraction, and then you can go all the way to be able to solve skill specific problems. But what I did with my paper is I actually defined this abstraction. I showed what it is, what it looks like at the most fundamental level, right? There have been a lot of speculations about what it was in academia. Like, okay, intelligence must be an abstraction. It must be something that can abstract and solve any problem, right? Would you agree with that?
I agree. Yeah.
Okay, so if that's the case, then the question becomes, what is that? Is it a math equation, or is it a symbolic model that we can derive math equations from, and also derive other possible systems that also are useful but might not just be fundamental? you know for example, you can look at physics and chemistry and biology as just different perspectives of the same thing, right?
Yeah, I understand that. Yeah. Like like if you if you have an uneven floor and you throw a ball on that floor, the ball will find the lowest point of the floor. So, from a kind of different perspective, that could be a form of intelligence because it's kind of in a physical way calculating the unevenness of a floor. So, but do you prescribe to the idea like everything has a certain level of intelligence from a rock to a person in terms of complexity?
Now that's a really, really good question right there. That's a really good question. And I think this is where I always lose a lot of people, is and when I start making the claims that the human mind is not it's really not that special. And that's because I don't believe that intelligence is local to the mind. It's not local to the mind.
I agree with that. I mean, yeah.
And okay, so if you agree with that, then it must be the case, if we agree with that, that a rock is also intelligent, because over time, um you know rocks change. We can make a lot of arguments, but from that perspective, a rock is intelligent, a seed is intelligent, right? All systems are intelligent, and they're being governed by the same rules.